Waves are caused by vibrations, and a wave carries the energy of that vibration from one place to another place, like this.
There are two categories of wave, mechanical and electromagnetic. Mechanical requires a medium like water, and electromagnetic waves do not.
A vibration can be thought of as the movement or disturbance of an object in a fixed time interval, which is known as oscillations.
There are two types of vibrations that waves can create. They are transverse and longitudinal. Transverse waves are waves in which the particles of the medium are disturbed perpendicular to the axis of the medium.
Longitudinal waves are waves in which the energy of the waves are that was supposed to be parallel to the axis of the medium.
Welcome back. Now you may be asking,
I know all this mumbo jumbo about waves and stuff, but what does one actually look like?
Well, there's the crest, which is the highest point of the wave.
and there's a trough, which is the opposite. It's the lowest point of the wave. When a crest and a trough of equal size collide, they cancel out.
This means that the amplitude, which is the maximum distance from the crest to the trough, is equal to 0.
That's right, Clay, but you didn't explain how big a wave is. It can't be this big.
Silly me. The distance from one end to the wave to another is called a wavelength, and the series of successive wavelengths are called a wavelength.
Wavelength? Interesting.
So, Juan, how do we measure how often these waves occur?
Well, it's nice you asked. They're measured in terms of frequency, which is in hertz. It varies, but it is again the time it takes to do a complete cycle. It is modeled by period equals time over number of waves.
Interesting.
Makes sense, guys?
What's up? It's Tupac. Can you get away?
If I matched the perfect frequency with something, could I rip it apart?
Of course you can, Andrew. It's called resonance. That's when the natural frequency of an object is matched and amplified by an external energy.
Ooh, do want.
Here, let me show you. I can shake the water with these sound waves.
Oh, it really shook. I really want to break something with waves now.
Sure you can.
Hey, I'm sure it's all fine and dandy, but how are we actually going to use waves in real life?
Well, your vocal cords use vibrations to create waves in the air in order for us to hear.
I never thought of that.
There are thousands of ways to use waves. You just need to look around to find its uses. For example, see this piece of junk? It uses electromagnetic waves to connect with other phones.
The possibilities are endless.
This was edited on my CPU, which does 3.81 gigahertz.